Hi, I'm Jared Lewis. I'm from Climate Resource, and we're part of the delivery team for the Climate Ref, of which I'm the delivery manager. I'm here today to present a new dashboard that we're launching as part of the version 1 of the Climate Ref. This has been a work in progress over the last 16 months, and it still is an ongoing project as we continue to refine this and improve it. The purpose of this portal is to provide the ability to see at a very high level some of the outputs that we're producing and we're calculating, as well as diving down into all of the different metadata that we track about these outputs. So then you could find the data that is of interest to you and use them for your analyses. As we're continuing to evolve this particular these outputs, there is a bit of a disclaimer when you first land on the website dashboard.climateref.org, describing the fact that this is an ongoing research project and these values may change in the future. We also don't, we have no responsibility for any misuse or use of these data as you rely on this. And I'd also note that these results we present here are intermediate results. We are currently going through a process of moving this deployment to be hosted at the ORNL ESGF node. So the results you see here and the URLs linking directly to some of these data will change in due course. We have a GitHub issue here to track that progress, and so the values that you see here may be different to what we see today. This particular disclaimer will be shown on your first page load, and we can accept that to land back onto our landing page. Now, this landing page provides us with an overview and some information about what the REF does. We have some links here to some other material that we've prepared to provide some additional information about the REF. We also have a Read the Docs page, which provides some more detailed information about behind the scenes at climate-ref.readthedocs.io. If you need more information, maybe go there and then come back to the dashboard.climateref.org. As we scroll down this page, what I'm presenting here today is the culmination of approximately 8,600 different execution groups. That is unique different runs of diagnostics that produce some output. So far, we're seeing about a 70% success rate across those execution groups. And there's some improvements and some tweaks that we'll make that hopefully raise that. But I'm just flagging that since we're doing this in a completely automated fashion, there will be some failures if the data set metadata isn't consistent, because we don't have a human in the loop for this particular process. So we're relying very heavily on good sound metadata. Currently, we're tracking about 500,000 different unique metric values. These metric values are either scalar values, so a value plus some associated metadata, some facets, or they are one-dimensional series metric values, and those also had some associated metadata that we can use to do some filtering and how we can choose what we show to display. Further down the page here, we have the recent execution groups that we've run, so we can see whether they're passed or failed. And these are the 5 most recent executions that we've performed. This may not make too much sense at the moment when we're statically calculating CMIP 6 results, but as new CMIP 7 runs come online and we're integrated with the ESGF new next generation infrastructure, as these data sets get published to ESGF, where we'll see new execution groups appear here, as well as the latest set of data that we've consumed. Moving up, and the best place to start is with our Data Explorer. This Data Explorer provides an overview of the thematic areas that were of interest to the model benchmarking testing that we developed through some consultation with the community. This is a high-level overview that brings together many different diagnostics into the same page. So this is a summary of what we're showing, and we'll get to the finer detail later on. I'll also note that what we're presenting here as a first pass at this particular at this data explorer. There will be still some holes that are filled as we continue to refine what we're presenting in consultation. I'd also note that if you have any thoughts or any feedback on how we could improve this, you can click through to our GitHub at climate-ref/climate-ref. That will, you can make an issue here to provide us with some feedback on what you're seeing, and if you see any errors, please also call them out there. So let's start at the top here. So you'll see in a lot of these dashboards, we'll see that we're using these box and whisker diagrams here to communicate or to aggregate together many different metric values. Each of these little crosses here is a metric value in our world. What that means is it's a scalar value here, 1.03, and the associated dimensions with it. So we can use this to show to slice and dice our data and present what we need to present. So here we're aggregating into these metric values into different seasons. And then these are all individual model runs that produce a RMSE value. We could, as part of those underlying model runs, we also produce bias or many other statistics. And we could, in fact, change these figures to show different things, or we could aggregate together by, for example, source ID to produce many little bars, one for each model. So what we show here can be modified. We have all of this is driven by some JSON configuration behind the scenes. So these charts here are very flexible in terms of how we show things. How do we group things? How do we filter the data? So as we refine what we want to show, we're able to easily adapt this to meet the needs of the community. So we also have some basic outlier detection. So what that means is we don't by default show any data that we have detected as an outlier. Users are still able to opt in to see some of those outlier values. So this value here, for example, was detected as an outlier because it was well outside the interquartile range. The process of how we do that outlier detection is still being developed and improved. But by default, we try to not show any outliers to make the graphs easier to understand as well. So another way that we may present information on the portal is via figure aggregation. So here we're presenting a range of figures from many different runs in the same card. So this card here has output from 4 different execution groups, and we aggregate them together. Where you may see in the coming days, in the coming weeks, that there is additional options for filtering here. So we could, for example, show just the figures for the, in this case here, the multi-model mean of 2 degrees, say, and we could show for each different variable at 2 degrees. Or we could show only the temperature ones. This kind of level of configurability is how we want to build and flesh out this Explorer as we go forward. And as I mentioned before, we're open to any feedback about what we should be showing in this dashboard to aggregate up all of this information behind the scenes. Another way that we're presenting information, another concept for this is that we have some Taylor diagrams, some dynamic Taylor diagrams. Each of these values here is 2 metric values, a correlation and a standard deviation for a given run, and presented in a dynamic way. So this is also each of these particular points here came from a single run of an execution group, and we are able to pull that together and show it in a clear and consistent way. These results that I've shown you so far are from 3 different diagnostic packages. But how we're presenting these data should be consistent across those packages. Another potential way that we can show some information is via these line charts. Here we're showing the seasonal cycle of sea ice area. We're able to then visualize, for example, different sources that are maybe potential of interest. This particular diagram doesn't have a reference line in it at the moment, but we're working on making sure that all of our values that have appropriate reference times data sets will be shown here. So some of the figures in due time will have a thick black line to represent the source, the different references there. So have a look around the Data Explorer and it will change over time. And there's still some placeholders. These boxes with the red, that's where we're looking to seek feedback around content that we should be putting in this, both in terms of the description of what it is and what we're showing. And if you now want to dive a little bit deeper into what is behind the scenes, I recommend we can go through to the diagnostic catalog here. This diagnostic catalog shows cards for each of the different diagnostics that were having run for the ref. These cards here, there may be many cards for a given diagnostic collection that the model benchmarking task team defined. With these are identified by these IDs here. So, for example, if we looked at the ENSO diagnostic, we can see that there's 4 different diagnostic collection. There's 4 different diagnostics that's part of that. We have a little card here, a little badge here showing which diagnostic provider the diagnostic came from. In this case here, we have ESM, Valtool, and PMP. These cards also show some additional information about whether or not we have scalar or series metric values, as well as the number of executions that have been performed for a given diagnostic. We also show some information about the reference data sets that were used, and that currently we have a relatively limited number of reference data that we're using, but we're looking to expand that in future. You're also able to group by, say, theme. That could be a useful way to navigate to the things that are of interest. And another one of the other diagnostics providers we have is ILAM. So let's have a look at, say, GPP, gross primary production, and we can dive into that. So the page that you land to here is a diagnostic overview. This provides all the information about that we have about a given diagnostic. So we can see here we've got some information about what the diagnostic collection description means, as well as a link out to some provider-specific documentation. We also show here how we group together unique runs, and I'll get to that in a second, as well as the number of execution groups that have run. So here we've run ILAM 98 times. There's been a few failures, but we've run ILAM 98 times for different combinations of experiment, source, member ID, and grid label. We have some reference data sets, and here we're showing all of the figures that were generated from those 98 different runs. So that can be a lot of figures. There's hundreds and hundreds and hundreds of figures here. These figures are the native output from ILAM. These are straight from the diagnostic provider. I would probably add here that the ref is actually just, the ref doesn't do the calculations itself. The ref is a framework where diagnostic providers are able to provide output in a consistent format that we're then able to visualize in different ways. So if we looked at a different diagnostic, you may see different types of figures because those are native to, say, ESM Valtool or PMP. But the figures in the Data Explorer as the aggregation of the individual values that these diagnostics provide. So if we can click on each of these figures, and we can flip through them to have a look at them. Again, we're going to have some features here to be able to filter this table so there's not 10,000 figures at once. If we click on the execution groups tab here, we're able to see all the different execution groups that were performed that drive all this data that we're showing here. So as I mentioned before, each time we have a unique combination of an experiment ID, a grid label, a member ID, and a source ID, we will generate a run. And we'll track whether that's successful or not here. The next tab here is the scalar values tab. This is a table showing all of the unique metric values that were produced, scalar metric values that were produced as part of those 98 runs. This table can be filtered as you see fit. So for example, we have a look through the table when we see a bunch of different statistics. Maybe we want to explore and only look at the global runs. So we apply a filter and then this table becomes filtered and we only have those runs. We also have you can also download these values if you want to use them in your own analysis. The ref was never intended to be a publication ready figure generation. We're trying to provide the tools that people can explore this data, extract what they need, and then make their figures outside of the ref in their own tooling that they need, be it Python, R, or however they want to do it. This tab here is the series values. Some diagnostics produce series. This could be monthly time series. This could be time series, or it could be annual cycles, or it could be stream functions, a bunch of different things. So here we see, instead of a single value, we see a spark line here describing the shape of the data, and you're able to download the values to see to actually see the actual values. And again, this table can be filtered as we see fit. Say we find a particular value that's of interest to us, we're also able to drill down into the execution that was run to produce that one single value. Each time we have a execution, we track all the information associated with it, such as the data sets that were used to produce that at that point in time, as well as all of the files that were produced for just that single run. In this case here, we're looking at a run that was for a given ensemble, a given member for Access ESM. And then we also have, again, the same things with the tables, but this is, in this case, is just the values for that single run. So we're through how we store everything in the ref, we are able to have a unique URL for each given output that we provide, where we calculate, and we do that, and we're continuing to work on how we can improve the provenance information that we produce as part of that in future, to be able to uniquely cite some of these values that we're using back to the run, tracing it right back. I would also mention that this is all backed by an API. This API here produces all these results in a standard machine readable format, and we're able to query these data in such a way to present to get the information you need. The portal itself uses the exact same API to present this data, but one could also make their own way of showing this data or querying this data. So we're developing some documentation at the moment describing how one could use say a Jupyter notebook to grab values directly from this API and make a figure. So this has been a brief overview of the dashboard for the Climate Ref. Again, dashboard.climateref.org. Have a look through, and we welcome your feedback, and any engagement on what you would like to see in there. And any feedback can be provided via our GitHub repository. That is the best way to contact the authors. and we look forward to seeing your feedback. Thank you.